Time Series Forecasting and ARIMA Model, a crash course. Introduction. Time series forecasting is a powerful technique used in various fields, including business analytics, to predict future values based on historical data. It involves analyzing patterns, trends, and seasonality in sequential data to make informed predictions. One popular method for time series forecasting is the Autoregressive Integrated Moving Average (ARIMA) model, which combines autoregressive, differencing, and moving average components. In this crash course, we will provide an overview of time series forecasting, introduce the ARIMA model and its algorithm, discuss the pros and cons of using ARIMA, and illustrate its application in predicting airport traffic forecasting based on an airport's month and passenger dataset. We will also explore popular time series forecasting techniques used in business analytics and conclude with a summary, a poem, and a song. Time series forecasting overview. Time series forecasting is the process of predicting future values based on historical data that is collected at regular intervals over time. It is widely used in business analytics to make informed decisions, optimize resources, and identify trends. Time series data can exhibit various characteristics, such as trends, seasonality, and irregular fluctuations. Introduction to ARIMA model. The ARIMA model is a widely used approach for time series forecasting. It stands for Autoregressive Integrated Moving Average and combines three components: autoregressive, R, differencing, I, moving average, MA. The R component captures the relationship between an observation and a certain number of lagged observations. The I component removes trends and seasonality through differencing, and the MA component models the dependency between an observation and a residual error from a moving average of lagged observations. The formula for the Autoregressive Integrated Moving Average (ARIMA) model is as follows: ARIMA P, D, Q. Where P represents the order of the autoregressive R component, which captures the linear relationship between the current observation and the previous observations. D represents the order of differencing, which is the number of times the time series needs to be differenced to achieve stationarity. Q represents the order of the moving average, MA, component, which captures the linear relationship between the current observation and the residuals from past observations. The ARIMA model combines these three components to capture the underlying patterns and dynamics of a time series data. It is commonly represented as YT equals C plus phi 1 YT1 plus phi 2 YT2 plus phi pi TP plus theta 1 ET1 plus theta 2 ET2 plus theta KTQ. Where YT represents the value of the time series at time t. C is the constant term or intercept. Phi 1, phi 2, phi p are the coefficients of the autoregressive terms. ET1, ET2, ETQ are the residuals or errors from past observations. Theta 1, theta 2, theta q are the coefficients of the moving average terms. The ARIMA model is estimated by fitting the model to the historical time series data and then using it to make future predictions. The parameters P, D, Q are determined through various techniques such as visual inspection of autocorrelation and partial autocorrelation plots, information criteria, for example, AIC, BIC, and iterative model fitting. It's important to note that the ARIMA model assumes that the underlying time series is stationary or can be transformed into a stationary series through differencing. Stationarity refers to a constant mean, constant variance, and autocovariance that does not depend on time. Differencing helps remove trends and seasonality from the data, making it stationary. By utilizing the ARIMA model, analysts can forecast future values of a time series based on its historical patterns and behavior, allowing for better decision-making and planning in various fields such as finance, economics, sales forecasting, and more. ARIMA model algorithm. The ARIMA model follows a simple algorithm. 1. Data preparation: clean the data, handle missing values, and ensure a uniform time interval. 2. Stationarity check: check if the data is stationary by analyzing mean, variance, and autocorrelation. 3. Differencing: if the data is non-stationary, apply differencing to make it stationary. 4. Model selection: identify the appropriate order of R, I, and MA components using autocorrelation and partial autocorrelation plots. 5. Model fitting: Fit the ARIMA model to the data using maximum likelihood estimation or least squares estimation. 6. Model evaluation. Assess the model's performance using statistical measures and diagnostics. 7. Forecasting. Generate future predictions based on the fitted model. Pros and cons of ARIMA model. Pros. ARIMA can handle various types of time series data, including those with trends and seasonality. It provides interpretable parameters that can be used to analyze the impact of historical data on forecasts. ARIMA models are relatively simple to implement and computationally efficient. Cons. ARIMA assumes that the underlying data follows a linear pattern, which may not be suitable for all types of time series. It may not capture complex nonlinear relationships and abrupt changes in the data. ARIMA models require stationary data, and achieving stationarity can be challenging for some datasets. Predicting airport traffic forecasting using ARIMA. To illustrate the application of ARIMA in predicting airport traffic, let's consider a dataset that contains monthly data on the number of passengers at an airport. By analyzing the historical passenger data, we can build an ARIMA model to forecast the airport traffic for the next month. This forecast can assist airport authorities in capacity planning, resource allocation, and decision-making. Popular time series forecasting techniques for business analytics. Time series forecasting offers a range of techniques suitable for different business analytics scenarios. Here are 12 popular methods. 1. Simple moving average. 2. Weighted moving average. 3. Exponential smoothing. 4. Holt's linear trend model. 5. Seasonal decomposition of time series, STL. 6. Autoregressive, R, model. 7. Moving average, MA, model. 8. Autoregressive moving average, ARMA, model. 9. Seasonal autoregressive integrated moving average, SARIMA, model. 10. Vector autoregression, VAR, model. 11. Dynamic linear regression. 12. Neural networks. Profit model, developed by Facebook. Each of these techniques has its own strengths and weaknesses and is suitable for different types of time series data. It is important to choose the appropriate technique based on the characteristics of the data and the specific forecasting objective. Summary. In this crash course on time series forecasting and the ARIMA model, we have explored the fundamentals of time series forecasting, introduced the ARIMA model and its algorithm, discussed the pros and cons of using ARIMA, and illustrated its application in predicting airport traffic based on passenger data. We have also highlighted 12 popular time series forecasting techniques used in business analytics. Time series forecasting is a valuable tool for decision-making, resource optimization, and planning in various industries. By analyzing historical patterns and trends, businesses can make informed predictions and adjust their strategies accordingly. The ARIMA model, with its ability to capture autoregressive, differencing, and moving average components, provides a flexible and interpretable framework for forecasting. Whether it's predicting sales, stock prices, or customer demand, mastering time series forecasting techniques is essential for businesses to stay ahead in today's dynamic and competitive market. By leveraging the power of data and advanced forecasting models, organizations can gain valuable insights and make data-driven decisions to drive growth and success. Poem. In the realm of time, where data flows. Time series forecasting, its beauty shows. Capturing patterns in a sequential array. Predicting the future, come what may. ARIMA, a model of great might. Autoregressive, integrated, moving with foresight. From stationarity to fitting the best. ARIMA's algorithm stands the test. Pros and cons, like two sides of a coin. ARIMA's power, but limitations to join. Linear relationships it assumes to see. Yet complexities it may fail to decree. Airport traffic, a tale we unfold. Passenger numbers, a story untold. ARIMA's magic, predicting the way. Helping airports plan for a brighter day. But ARIMA is just one of many. Time series techniques aplenty. Moving averages, exponential and more. Forecasting tools to explore and adore. From simple to complex, they all have their place. In business analytics, a winning embrace. With data in hand and models so fine. Time series forecasting, a key to align. So, embrace the power of time's embrace. With forecasting techniques, your future you'll trace. Let data guide you, decisions so clear. Time series forecasting, your business will steer. Start planning your next global adventure with ease and convenience with our Booking.com referral link, https://www.booking.com/index.html. A = 7989335 is a great choice to plan your next trip. You can find and book flights, hotels, cars, and local attractions all in one place, and their price match guarantee ensures you're getting the best deal. Thank you for kind support our ANHUB Metaverse channel, and please watch more interesting videos here.